Alright, continuing with Worksheet 6, our review for our Unit 13. We're on page 3. Limit as x approaches 2 of this. If I put 2 in for x, I get 0 on the bottom. I get square root of 4, which is 2, minus 2. I get 0 on top. So there's a hole. That's your thought process. If I get 0 over 0, there's a hole. So I'm going to manipulate this. And when I see a square root, I'm going to manipulate it by multiplying top and bottom by the conjugate. Leave your square root, change this sign to a plus, and multiply by the exact same thing on the bottom. Whatever you do on top, you have to do on the bottom. Okay. Alright, square root of x plus 2 times square root of x plus 2 is x plus 2. The middle term zeroes out. That's what we get when we do a conjugate. And then our last term will be a negative 4 divided by, and do not multiply this piece out because you want it in factored form. Okay? Up here on top, we have an x minus 2, and that reduces with the other x minus 2, leaving a 1 on top. Put 2 into the remaining x, and we get 1 over the square root of 4 plus 2, this is 1/4. Limit as x approaches 3. On the bottom we have a 0, on the top we have 3 minus 3. So we have 0 over 0, another whole. I'm going to multiply top and bottom by the conjugate, x plus, leave your square root the same. Whatever you do on the top, you need to do on the bottom. Okay. Multiply out the top. So the top is x squared. The middle term will zero out, minus the 6 plus x. Make sure you put that in parentheses or distribute your minus through because it's going to make this a negative x. Okay, on the bottom we do not distribute because we want to know what in the end we're going to be canceling out that x minus 3. Okay, now up on top we have x squared minus x minus 6, which factors into x minus 3, x plus 2. And now we can finally reduce out that x minus 3. We can cancel those out because x is not equal to 3. Otherwise, we could not cancel those out. Now we put 3 into the remaining x's. We get 5 over 3 plus 3, 5, 6. Okay. If we put pi in for x, sine of pi is 0, cosine of pi is a negative 1. We have a 0 over 0, so there's a hole. We're going to get rid of the hole. To get rid of the hole, when you have it like this, I'm going to multiply top and bottom by the conjugate of 1 plus cosine x, which is 1 minus cosine x. Okay, wherever you multiply by the conjugate, you need to go ahead and multiply it out. So 1 times 1 is 1, the middle term zeroes out, the back term is minus cosine squared x. On the other side, the bottom, I'm not going to distribute, I'm leaving it just like that. Okay, 1 minus cosine x. There's the Pythagorean identity that says that sine squared x plus cosine squared x is equal to 1. So we have 1 minus cosine x. If I move this to the other side, it'll be 1 minus cosine squared x. So that means that this thing right here is sine squared x. So this is sine squared x over sine x times 1 minus cosine x. One of these sine x's will reduce out, leaving a sine x on top. We can reduce it out because of what our limit says. So now I'm putting a pi in to all the remaining x's. Sine of pi is 0. Now on the bottom we have 1 minus cosine of pi is negative 1. 1 minus a negative 1 is 2. This is 0. Okay. Here in number 48 we have a one-sided limit. We're approaching 2 but only from the left. 2 but only from the left. Alright? So let's see what we get here. I'm going to begin by just doing what I always do, which is just plug in that value. 2 minus 2 is 0. 2 minus 5 is a negative 3. So this is 0 over negative 3, which is 0. It doesn't matter that we were coming from the left on that one. This is just 0. A is the answer. I don't have any little lines on these. We'll make our own little lines. Okay. Alrighty, next one. Now we're approaching 2 from the left. 2 from the left. Now the bottom will be 0. Is the top 0? No, it is not. So we have 0 on the bottom. I know this is DNE, but that's not one of my choices. However, I know it cannot be that, or that, because I have 0 on the bottom and not 0 on top. Okay, so it is DNE, but now we need to choose between the specific type of DNE. There's an asymptote here. Is this side going to positive infinity or negative infinity? And to figure that out, I plug in a number very close to 2 but on the left, maybe like a 1.9. Something very close to 2 but on the left. Up on the top, that is going to stay negative 3, because we can put the 2 in there. The top is negative 3. The bottom, though, it's approaching 0, right? But is it approaching 0 from the left or from the right? If I put a 1.9 in there, that's positive, yeah? So negative divided by a positive is a negative infinity, C. Okay, as x approaches infinity. Well, as x approaches infinity, only the highest degree term on top and the highest degree term on the bottom matter. These are the only two pieces that are relevant as x approaches infinity. The x cubes reduce out, leaving a negative 4 over 12, which is negative 1/3, E. That's the thought process I need you to think about, okay? In the past, in Algebra 2, you may have learned a rhyme involving same, co, bottom, o, whatever, okay? I don't want you to think of it like that. I need you to think of it like this. Only the most highest degree term matter. That's important because of why I know where we're going in calculus, okay? That worked fine in Algebra 2, but it's no longer fine, all right? I don't want you to remember a rhyme when it's just as easy to think about what's happening. Okay, here x is going to infinity. So I only consider the highest powered term on top and the highest powered term on the bottom. Okay, reduce your x's. Reduce your x's. And I'm going to have the limit as x approaches infinity of, when I reduce my x's, 3x squared over negative 12. Now let x go to infinity. If x goes to infinity, the top is going to be positive infinity, but we're dividing it by a negative. This is negative infinity, C. Okay? X goes to infinity, so only the highest powered term on top and the highest powered term on the bottom are relevant. Reduce your x's. We have the limit as x goes to infinity of 4 over 9x squared. Now let x go to infinity. The bottom is going to infinity. I have positives all over the place, but this thing is going to 0 regardless. A. Here x is going to negative infinity, so I'll have to remember that. But still, I only examine the highest degreed term on top and the highest degreed term on the bottom. I reduce my x's, and I get 3x squared over negative 12. Now I'm letting x go to negative infinity. X is going to negative infinity, but I'm squaring it. That makes it positive infinity. Positive infinity over negative 12 is negative infinity. If this ended up being a cube, though, negative infinity cubed would be a negative infinity up here. That would make the whole thing a positive infinity. Okay, x is going to pi over 3. Cosine of pi over 3 is not 0, so this is going to just give us a number. Cosine of pi over 3 is a half. Tangent of pi over 3 is square root 3. Sine of pi over 3 is square root of 3 over 2. I'm going to have to reduce this out. I'm going to multiply top and bottom by 2. So I get 2 square root 3 minus square root 3 over 1, which is 1 square root 3. A. Okay. We're going to pi this time. Cosine of pi is not 0, right? So I don't need to, gosh, my computer keeps losing charge very quickly. Okay, cosine of pi is not 0, so it's not a whole. I don't have to manipulate, I just plug in. Tangent of pi is 0, so I have 2 times 0, minus sine of pi is also 0. Cosine of pi is a negative 1, this is just 0. C. Okay, one more. X is going to 2. Well, ln of 2 is not 0, so I know that this is not going to be, ln of 2 is not 0. I know it's not going to be one of these. Okay, well, I shouldn't say that, but it's not, I don't have to manipulate. All I have to do is plug in. If I put a 2 up there, I have e to the 0. If I put a 2 in here, I have ln of 2. E to the 0 is 1. 1 over ln 2. A. And that is page 3.